Hello everyone. So the question is find median from data stream. The median is the middle value in a ordered integer list if the size of the list is even, there is no middle value, and the middle value is the mean of two middle values. For example, in 234 the median is 3, in 23 the median is 2.5. Implement median finder class. Median finder initializes median finder object, void add num, uh, adds the integer to the data stream, from the data stream to the data structure. Double find median returns the median so far. Answer within 10 power minus 5 of the actual answer will be accepted. Median finder of add num find median, so 1 2, the total number of terms will be even, so we can take a median of 1 and 2 and then add num 3. So 1 2 3 in sorted form will be, the median will be 2. So yeah, now the idea is that the constraint is the number value will be 10 power 5 to 10 power, yeah, like minus negative 10 power 5 to positive 10 power 5. There will be at least one element in the data structure before calling find median. So yeah, we don't need to worry about the edge case that there is no element added, and at most 10 power 5, we can round this off to 10 power 5 calls will be made to add num and find median. So here the first thing to notice is that because we want to find the median, we need to have this array in a sorted order, and so essentially one of the ways to do this is to have a sorted array and then to find the index where the current element should be added, and then to insert, but and then to insert it at the correct index. But the issue is that this insertion step will always be O of n time, and so that would be and like if we are making 10 power 5 calls, so at every step this will be O of n. So another approach for this is to have a heap, min-heap for top half and max-heap for bottom half. So what we can just do is that we can always check the total number of elements that are present by taking a sum of these two heaps, and if that is even, then we can if that is even, then we will have to take the mean of two values, so that will be the mean of top half and bottom half, and even then mean of right. Now if this is if total number of elements is odd, right, then basically we should return, so the idea is that we can, so let us try to figure this one out. So the idea is that we can always insert uh, to the min heap first, which is like yeah, sorry, we can always insert to the uh, max heap first, which is the minimum, like the bottom half, and after that we can check the size of insert in bottom half first, right? So that we will always get the maximum in the bottom half, and then essentially we will check the size between these two heaps. Right, so the idea is that essentially if the size between these two heaps is greater than 1, right? So essentially what we want is that if greater than 1, right, then we can, so then we can pop from bottom half and push to top half, right? So the idea is that, like, let's say if we have 1, we will push 1 to the bottom half, and the size difference between 1 and between the two heaps will be, so let's say these are the two heaps. So after this we will push 1, and then essentially we will push 2. So this is a max heap, so essentially 2 will be at the top. So we will, now the size difference between these two will be 2, so we will pop 2 and then we will push 2 over here. So now the min heap will have 1, like 1, and the max heap will have 1 and the min heap will have 2. So after this we can take the median, which is the mean of 1 and 2. After this, when we add 3, we will have 3 and 1, and then there will be 2 over here. So now essentially there is an issue here. The issue is that 3 is essentially bigger than 2, right? So like when this condition happens, that the top, so there's another check that we need to do, that if the check if top of bottom half is greater than top of top half. If this is the case, then we need to swap these two values. So finally what we will be left with is 2, 3, and the number of elements here will be 2.5. The number of elements here will be 3. So whenever this is the situation, we will always have, if we have odd number, we will always have more elements in the one, like half plus 1 element. Like we will always have one more element in the max heap, which is the bottom half. So we will just return the maximum value of the bottom half. So yeah, let's try to implement this. So now adding, so basically we can do a heap push in right. So this is the heap, and then the element that we want to push is negative of num. So yeah, this is just the Pythonic implementation uh, that for max-heap we have to push the negative value because it always implements a min-heap. And then so now we can check two things, that if length of so if the length between is greater than 1, right? So in this case what we can just do is that we can pop so we can pop this guy, right? And so we basically we can pop this guy, take a negative of this so that this will become positive, like this will become the true value, and then we can just do a heap push normally. Right, so now this thing, so this is the first condition that we described at 2, right? Now the second condition that we described at point 3 is that if self dot bottom half, right, 0, so this is the top value, right? So we can take a negative of this because this is going to be like this will give us the true value. If this guy is greater than self dot top half 0, right? If this is true, which means that we have yeah, so we this means that we'll need to swap these two guys. So top half, so we can call this max bottom half and min top half just to be clear and readable. And then essentially what we need to do is that we need to do a heap push in the bottom half, in the bottom half what we can push is the minimum value of the top half, but yeah, but because the bottom half is a min heap, we will add the negative value. And then because sorry, it's because it's a max heap, and because the top half we will push max bottom half, and we have already taken one negative, so we don't need to take another one. So yeah, this is the case. Now in this case we need to add a check here that these two values actually exist and this array is not empty. So we can just do that before we can do that this way, that the bottom half and the top half both are not empty. And yeah, so here we are not expected to return anything, right? So now if length so now we are good. So now the here we have to return a floating value, so we have to take that into consideration. So if these two numbers are basically if the total number of elements are odd, right, then what we have to return here is the bottom half, this basically the top of the bottom half but the negative value of that, right? Else what we can just return is so basically if we just take a normal divide by 2, this itself in Python will give us the floating value that we want. And then bottom half and top half we'll do this way. This will give us a normal summation, and then we can just divide that by the normal division. That should give us, and because we have this condition that there will be at least one element in the data structure before calling find median, we don't need to do any null checks over here, but at line 30 we need to do some null checks. Let's try to run this. This is running okay, and this is running fine too. So yeah, these this is the solution. Thank you. The runtime complexity for finding for adding number can, as you can see, we need to push in the bottom half. So this, like whenever we are adding a number to the min heap, to a heap, this will be log of n, and then essentially whenever we are doing a pop, this will be also be log of n, and then this will also be log of n. So all these operations are being performed are actually log of n time. Similarly, when we find the median, we are just checking the top of the heap, so this will be order of 1 time complexity. Thank you.